Hey, good morning, everybody. This is Mr. Aynesworth, and we're going to get started here in financial algebra and cover section 6 here and talk about break-even analysis here. So let's get started. Make sure you have your Desmos up and running here. I already signed in and notice that I've already titled everything, so go ahead and do that because we always use Desmos here and save and submit our Desmos work to validate everything. Okay, so we're going to put all our ideas together in sections 4 and 5 and bring them in, and we're going to continue talking about what does it mean to break even and what quantity is required in order to break even, where revenue is equal to expenses. Okay, so key concept here, the concept of break even means that revenue is equal to expenses. So let's put that in red first. Okay, the concept of break even is, find Q, all right, find Q, well, I better put down here, find the quantity demanded, okay, quantity demanded by the public, all right, so that you break even, which means revenue here, revenue must equal to expenses. So when does that happen? At what quantity does that happen? Okay, so the goal in this section here is to do exactly that. We're going to do it algebraically, and we're also going to use Desmos, and we're going to do it graphically both. So get ready, here we go. All right, number one, AVS Industries has determined that a combined fixed and variable expenses for the production sale of 800,000 items, okay, so we're selling 800,000 of them, is our 24 million bucks, 24 million bucks, okay. What is the price at the break-even point? Okay, so in this question here, we're not trying to find the quantity, we're trying to find the price. Okay, what is the price, P? Okay, so we don't know what that is. So P equals question mark at the break-even point. Okay, and that means revenue equals expenses. So this portion right here, the fact that we have we want to figure out the price at the break-even point. Well, we know we're selling 800,000. Okay, so we know Q, we don't know P. All right, but we do know that we want to break even, and because of that, revenue, let's write this down again, all right, must equal to expenses. And so anytime you see the words break even, all right, if you know you have a break even situation here, revenue equals expenses. And as you guys know, revenue is nothing more than price times quantity. All right, and the expenses, well, it says right here, the combined fixed and variable expenses is $24 million. All right, so this is known as well. So we know that P times Q, revenue, is equal to 24 million. All right, so we also know that we're selling 800,000 of them, so we know the quantity, we just don't know the price. So it's always price times quantity or quantity times price, however you want to write it. So in this case, we don't know the price, but we got to multiply it by 800,000, and that's going to be equal to 24 million. Okay, now to solve for P, you simply divide by 800,000 and you're done. All right, so P is equal to 24 million. All right, divided by the 800,000. Let's see if we can do this in our head. So, what would it be? Okay, well, you can cancel out zeros, right? So cancel out 3 zeros, well, actually 5. 1, 2, 3, 4, 5. All right, 1, 2, 3, 4, 5. And you get 240 divided by 8. And 240 divided by 8 is 30. So the price is 30. Okay, so there we go. That's your first problem there, dealing with what's called the break-even point. Okay, so 240 divided by 8 is 30, so the price is $30. All right, if you price it at 30 bucks, boom, you're going to break even. And that's going to happen when you sell 800,000 of these items. Okay, problem number one. Okay, number two. We're gonna go through as much as we can here and give you guys some experience. Okay, number two, the expense equation for production of a certain audio player is given. Okay, so cool, we're given an expense function. All right, where Q is the quantity demanded. Q is always the quantity demanded. Remember that, Q for quantity, but we call it the quantity demanded. At a particular price, the break-even revenue is 3,800,000. What is Q at the break-even point? So this is very similar to what we just did. Instead of finding P, now we're finding Q. All right. Okay. So now, all right, we know we're dealing with a break-even point, so we write this equation down one more time. So the revenue is always equal to expenses. And as soon as you have a break-even point situation, that's what you write down, okay? That only occurs when revenue meets expenses. Money coming in equals money going out, okay? Remember, expenses is money that you're spending, okay? Because business costs, to run a business, it costs a lot of money. Revenue is the income coming into the company, and when they're equal, you break even. You're not losing, you're not gaining, okay? Now it says, what is the quantity demand? It says right here. We always have to focus in on what we're trying to find. It says, what is the quantity demanded? Well, I don't know what that is. So Q equals question mark, right? We don't know what that is. Okay, but I do know that the revenue is equal to, let me see, the break-even revenue, okay, is 3,800,000. So we're given the break-even revenue. So 3,800,000. There's your revenue because it gives it to you. Look right here. All right. But we don't know the expenses, but we do know the expense equation. So we know it's 1,250p plus 700,000. All right. So what we want to do is solve for P. Excuse me, not P. Excuse me, it's Q. Come on, I've got to get my game on here. Okay, so it's this is in terms of Q, not P. So we got to find Q. All right, let's subtract 700,000. So if you do that, this you can do in your head. Okay. Hopefully. Okay, and so you get 3,100,000 is equal to 1250Q. I'm going to go off to the side. I'll just rewrite this equation here. So we have 3,100,000 is equal to 1250Q. Divide by 1250. Kick in a little bit of calculator work. So like I said, so 3,100,000 looks good. Divided by 1250. All right, and notice you get 2,480. Okay, so with the Q here, Q is equal to 2,480 widgets in this case. Okay, so 2,480. Let's see what we're dealing with here. I forgot. So you got to reread the problem here. So, oh, it's an audio player. So, this is audio players. Okay, there's your quantity. So if you produce that many, all right, you're going to break even. All right, number 3. Moving right along. Okay, a manufacturer determines a product that will reach a break-even point if sold at 30 or 1,200. The expense. Actually, you know what? Let's go ahead and do it. I would say the manufacturer determines a product that will reach break-even point if it's sold at either $30 or $120. Okay, so at $30, the expense and revenue values are both $120,000. So here we go. So if the price is set at $30, you get a revenue, which is the same as the expense, because the break-even, they're equal, right? And it's going to be $120,000. Okay, that's if you set the price at $30, but if you set the price at $120, all right, the revenue, which is going to be equal to the expenses, it's going to be a lot higher. It's going to be $400,000. All right, graph possible. Look at this, graph possible revenue and expense functions that will depict this situation, and label the maximum and values. Okay, so what we're going to do is we're going to make it easy, and we're going to use the technology and use Desmos. And we are going to use linear and quadratic regression. Okay, so here we go. Let me put this off to the side, and let's get ready. So let's go into Desmos here, and let's set our information up in the form of a table. Our first point is 30, 120,000. Okay, that's our first order pair. So if the price is 30, the revenue and expenses are 120,000. All right, this is the easiest way to do it. Of course, you can do this by hand. We'll do that on another problem, but right now I choose to use my linear and quadratic regression skills here that you guys already know. So let's just apply something you already know, meaning linear and quadratic regression. So you put your 2 points in as ordered pairs, and then you calculate the linear function, okay? And the linear function is going to be your demand function, or excuse me, your expense function. And then your quadratic function is going to be your revenue function. So before we do this here, let me just show you. We're going to go off to the side here real quick. I'm going to just sketch the situation here. So just to show you how you can sketch this by hand. So you're going to have price here, and quantity, or excuse me, not quantity, but you're going to have expenses or revenue up here on the vertical, and they're obviously going to be in dollars. Price is going to be in dollars too as well. And if you plot this and just do a quick little sketch, 30 comma 120,000 could be right about here. So let's say this is 30, and you go up 120,000. So let's say you count by 30,000s. No. Let's say this is 100,000. Okay. So 120,000 would be a little higher. And then if you go to the right, 120,000. Okay, so 30, 60, 60, 90. Ooh, 30, 60, 90. Look at our label. Okay, 120. And then you go up 400,000. So you go up here, 200, 300, 400. It's going to be up here. And so your expense function is going to look like this. Okay, so there's your expense function as a sketch. Now the revenue function is going to look a little bit different. It's going to be a downward facing parabola, and it's got to go through the origin here. So it's kind of looking kind of weird here. No. It's probably going to be something like this. Okay. So you got a revenue function here. So it's going to have 2 break-even points, one at A and one at B. And it's kind of weird because the expense function usually has a downward negative slope instead of a positive slope. So this is a very, very uncommon and weird situation here. But this is one possibility. Now, if you graph this and you take a look at what Desmos gives you, let's it may be similar to this. I don't know. We're going to find out right here. So that's one possible situation, but here's what Desmos predicts. Okay, so we're going to use linear regression first. So we're going to type in y1. Okay, we're going to use linear regression to go shift tilde. All right, mx1. All right, plus b, and we're going to get our linear function right there. We'll write it here and take a look at it here in a minute. And then on the second line, we're going to go y1 is approximately equal to, so go shift tilde ax. ax1 to the second power, there's your quadratic term, all right, plus bx1, all right, plus c, and there's your quadratic function. Now, let's take a look at the graph and see what Desmos predicts. Okay, remember, this is just a prediction, okay? And so notice that we can't see anything because we haven't adjusted the scale. So we're going to go over here to the wrench, and we're going to adjust the scale a little bit. So right there, we're going to go from 0 to well, we got to go past 120 because remember the second price is 120, so let's go to 200. All right, and we'll just step it out by 5s. All right, and we still can't see the graph because we have to adjust the y-axis, so let's go from 0 to something big. I just start with 10, and then I keep adding zeros until I can see what's going on. Okay, and that's 100,000 or a million right there. So let's take a look at it. Holy cow, look at this. Okay, so you're going to have to adjust, if you're going to see the entire revenue function, you're going to have to go from 0 to 600. So let's just do this here together manually. So let's go 0 to 600 on the x-axis. And then on the y-axis, let's go from 0 to 700,000. Okay, so type in 700,000, and you should be seeing exactly what I have up here. And so notice the the break-even points, just click on them. You'll notice that it looks similar to what I produced, okay? And there we go. So the red function's the expense function, and the linear, or your curve here, your parabola, your quadratic curve, parabolic curve, okay, your revenue function, all right, is in blue. All right, there we go. So I sketched it first by hand without even looking at Desmos here, just by plotting a couple points. And then of course you can use linear and quadratic regression. Oh, by the way, we have to write that function. So let's go ahead and clip this in. And let's make sure we know how to write the function, okay? So before we go any further, let's go ahead and do that here first. Okay, so in this case right here, this is your linear function. Okay, this is your expense function. And what we're going to do is take these values and substitute them in. So your expenses, I'll write it y in terms of x first, and then I'll translate variables here. So y is equal to 3,111.1 times x plus 26,000. It doesn't ask us to do this, but I'm just going further here. 666.70. And so if you're going to write that in the right variables, here we go. So instead of the y-axis, we have the expenses are on the vertical. Okay, instead of x, we have p, because p is on the horizontal. So p times p plus 26,666. I'm rounding a little bit. Now in terms of the revenue function, we have a quadratic, and we got to take all of these values and substitute them up here. So a right there is negative 7,407 roughly. Let me see. No, 7.4. We'll just estimate a little bit. Okay, so negative 7.4 times x squared. And then b is big. All right, so 4,222 times x, and c is 0, so plus 0. And then on the y-axis, instead of y, we have revenue, okay, equals negative 7.4 times p squared plus 4,222 times p. Again, variable switch here, guys, because on the x-axis, it's not x anymore, it's price. On the y-axis, it's revenue or expense, depending on what function you're writing. Okay, and so there we go. Use linear and quadratic regression, okay? This is called linear regression. Anytime you do this, it's called regression. All right, and this one here is called quadratic regression. Both of which you guys know because we did it before. Okay, so now let's try a few more, okay? So let's go back to number 4 and talk about how to estimate the break-even points, okay? Estimate the break-even points where the expenses and revenue, for the expense and the revenue functions. Okay, so we got an expense function here in the line. We have a revenue function here, and they intersect at 2 points, A and B. And it asks us to estimate, okay, the break-even points. So let's do that. So at point A, what is it? And then at point B, what is it? Okay, so let's zoom in here a little bit here. So what we do is you got to go down. So you put your pencil at A, and you simply go down, straight down, and you read the graph. And I estimate it maybe between 1 and 2. We don't really know, but let's say it's about 1. Okay, either 1 or 2. Don't really know. And here it's let me see, 50,000. 50,000. Holy cow. Okay, and then so if this is 25,000, so in the middle here is 75,000, and it's a little higher than 75,000, so maybe 800,000 or 80,000. So point A here could be, all right, 1 comma, let's say 80,000. Okay, point B, the other break-even point, you pretty much do the same thing. All right, you want to go straight down to the axis. All right, that could be about 14 or 15, don't really know, but it's got to be close. And then you got to come over here and it's very close to 50,000. Okay, don't know if it's exactly 50,000. If it's a little bit under, it could be 49,000. Really don't know. But if the price is 14, then the revenue here is approximately a little under 50,000. Let's say 49,000. Okay, there we go. Price and then revenue. Okay, and those are the break-even points. And again, it says estimate, right? Estimate. All right, these are not exact. Okay. Now over here on the right, on part B, we got an issue here because over here we got the expenses. It's the linear function. We got a revenue function here. And notice that no matter what the price is, let's analyze this a little bit here. Let's say the price is at 5. So we draw a vertical line at 5. So if this is the price, notice that the expense right here, expense at 5, is higher than the revenue at 5. Okay, and so no matter where you look on this graph, okay, expenses are always greater than revenue. Okay, and this is a bad situation right here. You do not want to be in this situation. All right, because in this case right here, since the expense function is higher than the revenue function, first of all, expenses are always greater than revenue. Bad. Okay. Secondly, there are no break-even points. Okay. There are no break-even points. All right, because the revenue function and the expense function do not intersect. All right, the expenses are higher than revenues at all prices. Okay, expenses are greater than revenue at any price. Let me write that down. At any price. In fact, let's put it in red. Okay, at any price. Not good. Okay, not good at all. Okay, so we have two different scenarios there on number 4. All right, and let's move on. Okay, we're going to skip 5. We're going to go into number 6. All right. Now I'm going to do number 6 with you, and then you're going to do number 7 because they're very similar. Okay, so here we go. Let's start reading the problem here, and let's tackle it together. All right, here we go. Sunset Park Equipment here produces camping gear. They consider manufacturing a new energy-efficient lanterns. We're dealing with lanterns here, guys. Okay, and then the expense function is given, so we know the expense function. And guess what? The revenue function is given. Ooh, nice. Okay, so we know a revenue function. So sketch the graphs and the revenue function. So we're going to use Desmos here. And what we want to do is figure out the prices at the break-even points. Okay, so here we go. Let's put this off to the side and let's get Desmos running. All right, make sure you save your Desmos. Okay, go down here to the second one here. And again, I'm going to write the functions in a unique way. So expenses is going to be negative 54,000. All right, times P plus 7 million. And then the revenue is the quadratic one, negative 1,800 P squared plus 200,000 P. So when we put this in Desmos, we're going to type it in as y equals negative 54,000 times x, all right, plus 7 million. Over here, I'm going to type it in as y equals negative 1,800 x squared plus 200,000 times x. Okay, so just a little variable switch here. Here we go. So let's type it in and let's work with it. And by the way, you should turn off your colors on the previous problem. Don't delete anything, just turn off your colors so that you're looking at only one function at a time. Turn off your points too. So here we go. Let's type in our expense function first. So y is equal to negative 54,000. Okay, times x plus 7 million. Okay. Yeah. Oh, I made a little mistake there. Gotta type in equal sign. Okay. There we go. All right. Now, if you want to see your entire function, just grab this bar here and bring it off to the right. Okay, so we got our first function in there. It's called the expense function, and then we got to put our revenue function in there. and then so we can get started. Okay, so y is equal to, all right, negative 1800 times x squared, all right, plus 200,000x, so plus 200,000x, okay, boom. Okay, we're going to go to expand this, so we need to be able to see these graphs here. And notice that can't really see much here. So we got to expand it here so we can see things better. And then let me check to make sure I enter the function in correctly here. So negative 54,000, x plus 7 million. That looks, ooh, got to put negative 54,000, okay? Not positive 54,000, negative 54,000. See, always check your work here. All right, and then the other one is negative 1800 x squared plus 200,000 x. Oh, shoot, look at that. I didn't even put that in here. So once again, you got to check your equations like I just did there. And notice that I can't see what's going on because I have a y-intercept here of 7 million. So we're going to have to go and change our settings. So change it from 0 to maybe, I don't know, 8 million. Because you have to be able to see your graph. So put 8 million in there, and your step, I don't know, maybe 1,000. Okay, and your y-axis here, oh, excuse me, that was wrong. I was thinking about my y-axis here. My y-axis is from 0 to 8 million, because my y-intercept is huge, guys. It's 7 million, so your y maximum has to be big. I'm going to set it at 8 million, okay? So you can see everything. All right, and then on your X max, let's just set it to, I don't know, 50 maybe? No, 50 is not big enough. Set it to 100. No, not big enough. So let's try 200. Ah, there we go. And so you got to get really good at this here. So notice that the Y max depends on the y-intercept of the linear function. So if the y-intercept's at 7 million, you set it bigger than that, okay? And that way you can see everything. Now this problem here is determining the prices at the break-even points, and we have two. Okay, one here and one here. And that's all it asks. So let's go ahead and screenshot this and bring this in, and we can annotate and answer all the questions. It's that simple, actually. Okay, well, this one, that is. Okay, so let's go back to our lesson. All right, and let's annotate our graph. Okay, so here we go. So I've got my graph. Here we go. So we have a couple break-even points on this one here. So let's label. Okay, you guys can sketch this curve in your spiral. One at A and one at B. And it's always price and then revenue. And price and then revenue. Okay, so on this one here, on the first one, what is it? It says determine the prices. Look at that. At the break-even points. So we'll call the first one P1 and call the second one P2. Kind of makes sense, right? Right. Okay, so P1 would be approximately $37.55. So $37.55. Okay, and we have another one at P2, and that's going to be $103.56. So $103.56. Again, you always round to the nearest hundredth, okay? So round to the nearest hundredth. Okay, because you got to go to the nearest penny man. Okay, now for each one of these, you have a revenue that occurs. Okay, so on part C, it says find the answers or use your answers in part B to determine the revenue and expenses for each of the break-even points. Okay, so this one gives you the first revenue, and this one here gives you the second one. Okay, so we'll call this one R1 and R2. All right, so here we go. It looks like the first one here, oh, it's a big one. Okay, so for this one here is approximately 4 million, it looks like, 972,000. All right, $161, and looks like 61 cents. Okay, huge. All right, put dollar signs on these. Second one, not so huge, but still big, 1,407,000. And it looks like $838. All right, and 39 cents. There we go. That's all there is to it. So you just enter the functions in, click on the break-even points where they intersect. Okay, these are called break-even points. Okay, this one here, A and B. So it's where the expenses, right? Expenses is equal to revenue. Key concept right there. All right, and then you just write down your information. All right, now you do number 7. I'm not going to cover that. It's very similar to number 6, so you do this on your own and you check the publisher. Okay, let's go to our main problem of the day, and that's number 8. And so we're going to spend some time on this because it's the only challenging thing in this lesson, because it derives, or it depends on actually, your algebra 1 and 2 background. Okay, so here we go. I'm going to show you how to do this algebraically. So it's approximate the expense and revenue functions in the graph. Okay, so let's annotate it first. So you have your expense function here, revenue functions, the parabolic one. So this one here is your revenue function. And it's going to be some quadratic function. All right, and then we've got our linear function down here, and it's called the expense function. And it's linear, so this one's linear. All right, and the curve, the revenue, this is it's a parabola. So y is equal to ax squared plus bx plus c. It's called a quadratic. Okay, as you guys know, and we call those parabolas. All right, so here we go. Let's get to work. Now, what we need to do here is we need to tackle them one by one. We'll talk about the expense function first, since it's linear. And in a linear function here, all we have to do is analyze the slope and the y-intercept. So any linear functions always equal to y equals mx plus b, where m is your slope. So we just need to calculate the slope of the line. And then we have to calculate or just look at the y-intercept. So let's do the easy part first, okay? And let's take a look at our expense function. So if you need to do this in your spiral, get your spiral out, because there's going to be a lot of work to be done here. Okay, so the expense function is linear. So what we want to do is analyze the y-intercept and the slope. So here, the y-intercept is 10,000. So I can see that. This is called a y-intercept. All right, and so here b is equal to 10,000, right there. All right, now the slope, you got to pick 2 points on the line and calculate rise over run. So remember, slope of a line is equal to rise divided by run. Okay, in this case, since it's negative slope, we're going to go down and then to the right by picking 2 points. So you want to pick 2 points on the line that we can use to determine the slope. Like if you just cruise along the line here, you got to pick 2 points. So maybe this point right here. So point A and then point B, and then you do a little rise and run and calculate the slope. Okay, so let's calculate a little bit of slope. We're going to go down, okay, and guess what? That's a negative. So from 10,000 down to 8,000 is a negative 2,000. And then I've got to go right, let me see, from 0, 1, 2, 3. Holy cow, we got to go right 3. So the run is 3, and the rise is a negative 2,000, all right, because you're going down and not up. So in this case, for my slope here, it's a negative 2,000 divided by 3. And it should be negative because this line goes down to the lower right. Okay, so now I have enough to write my expense function. Okay, so that's the easy part. All right, so here we go. So the expense function, E, is going to be equal to my slope, which is negative 2,000 divided by 3, all right, times x, not x, but p, because remember, this is price. Price is down here, so times the price plus my y-intercept of 10,000. All right, it's linear. Okay, so instead of y equals mx plus b, it's E is equal to m times p plus b. Okay, again, instead of the y-axis, we have the expenses. Again, this is expense, or it's equal to the revenue, depending on what function you're looking at. All right, and then instead of x-axis, we have the p-axis, because the horizontal axis is price. All right, so there's your first function. Now the challenging part, and that's going to be your revenue function. And your revenue function is parabolic, and you could use a standard form of a parabola, all right, but that's harder to use. So I'm going to show you another way that you learned in Algebra 1 and Algebra 2. All right, so let's work on our revenue function here. All right, and what we're going to do is we're going to use the what's called the what do we call it? Lost for words right at this moment. Okay, so we want to write the revenue function, which is a quadratic function, but we're not going to use standard form. We're going to use what's called general factored form. Okay, so I'm going to write that down off to the side. So general factored form, okay, of a quadratic. And we're going to use this because it's a lot easier. Okay, now the general quadratic form looks like this. Y is equal to a times x minus r1 times x minus r2. That's for any quadratic function, where r1 and r2 are called roots of the function. So r1 is the first root, okay? r2 is called the second root of the function, okay? And by that I mean x-intercepts, okay? So where does the function intersect the x-axis? Okay, and so we know that the function, if you just look at it right here, intersects at the origin right there. Okay, at point, we'll call it C here. Well, no, let's call it R1. Okay, so R1. So R1 is here, and then R2 is here. And notice R2 is 9, okay, because it intersects at 9. So R1 equals 0, R2 equals 9 because it intersects at 0 and 9. Okay, so this function here, form called factored form of a parabola, is quite easy to use. All right, R1 and R2 are called the roots, and it's where the parabola intersects the x-axis. Okay, no problem there. A right here is a point on the graph. Okay, so this A right here is determined by a point on the graph, and that right there should be negative because the parabola opens down. So whatever we get for A should be negative something. All right, so the first step we do is we just substitute our roots in. So let's substitute the roots in. So y is equal to A, we'll find that in a minute, times x minus 0 times x minus 9. All right, now we simplify a little bit. So y is equal to A times x. X minus 0 is obviously x, okay, so times x here. All right, times x minus 9. Can't really do anything there. So now we got to find A. Now to find A, we pick a point on the graph. So to find point A, or not point A, to find A, all right, we use a point, all right, on the parabola. Okay, so we got to pick one. So let's zoom in here and let's pick a point that we know, other than 0, 0, and other than 9, 0. So you can't use the roots. You got to find another point. And so you cruise along the graph. You just get your eyes and you cruise along the graph and you pick a point on the parabola that you know, okay, that you know. Like, for example, I don't know this point right here. I have no idea what that is. I don't know what this is, and I don't know what this is, and I really don't know what this is. I don't know what those points are. All right, so you keep on cruising up on the graph, okay? You keep on going, and you stop at the first point you know. Like, I don't know all these points, but I do know this point right here. And let's give it a name for reference here. Let's call it C, okay? Now, C is simple. So you go down to the x-axis. Oh, it's 1. And you go left. Oh, it's 8,000. So C is 1, 8,000. And this is on the parabola. Okay? So you pick a point on the parabola that you know. We know this. We know the coordinates because it lands on 1, 8,000. And so that's what we're going to use over here to find A. All right? So our goal right now is to find A. I don't know what it is. It's some negative number because the parabola opens down, but I don't know what it is. Okay, so we're going to use 1, 8,000. All right, and then x is 1, y is 8,000, so here we go. So I substitute 8,000 in. Okay, don't know what a is, but I do know x is 1. So times 1 times 1 minus 9. Okay, simplify. Get 8,000 on the left. 8 times 1 is a. 1 minus 9 is negative 8. All right, divide both sides by negative 8. And I get negative 1,000 equals a. So now what I want to do is take this. Okay, I know what a is, and I substitute it in. So now my function looks like y equals negative 1,000 times x minus 9. And then if you distribute through, we have the function. We're all done. Okay, so let me do that here. I'm just trying to get some more room. Okay, so here we go. Distributing through, y equals negative 1,000. X times x is x squared. All right, negative 1,000 times negative 9 gives you 9,000x. Okay, and there is my function. This is the revenue function. Now let's switch variables here. On the y-axis is the revenue axis, so R. On the x-axis is the price axis, so we're going to switch to P. And my friends, we just found the revenue function. Okay, this is the revenue function. So what I'm going to do now is I'm going to plot both of these functions in Desmos and show you how it looks just like the given graph up here. All right, so let's go do that. Okay, so let's go to Desmos. Let's turn off our colors from the previous graphs. Hit the save button. All right, and let's enter these two functions in. So the first one up there, the expense function, y is equal to negative 2,000. Make sure you hit the negative button. So negative 2,000 divided by 3. Okay, times x plus 10,000. Okay, on the next curve, we go y equals, all right, negative 1,000. All right, times x squared plus 9,000 times x. Okay, and then expand it, and let's see, we're gonna have to change the scale. Okay, I have a touch screen. You're gonna have to do this manually. Okay, and we have, let me see. So we have the correct y-intercept here. Let's see if we have the correct roots. We have the correct roots, correct y-intercept. There we go. And that, my friends, is how it's done. Okay, so let me bring this in just for funsies here. All right, let's get our do a little comparison here. Let me just put it side by side so you can see this. Give me a second here. When I'm recording a video, it's a little bit slow because we got a lot of things going on. All right, but notice our graph here, they're the same. Okay, so again, these are the functions. So I put the functions in Desmos and just to verify everything. All right, and so make sure that you understand and fully understand number 8. Number 8 is the key problem here. It's where we actually calculate the revenue function using some things we knew from Algebra 1 and 2, because I teach this in Algebra 1 and 9th graders, what's called factored form here. And we're just using points on the graph to generate the slope of the linear function, looking at y-intercepts, using all our basic skills from Algebra 1 and 2. And putting it all together in finance. How about that? We're actually applying the math that you guys learned over the past couple years. Okay? All right, and of course we'll practice some more too. Okay, this is Mr. Aynesworth. Make yourself proud. Go through this lesson, finish the ones that you had to finish, and I'll see you in section 7 later on. Take care. Bye bye.